Okay, now we get into polarity. I'm on page 13 of your unit handout. This is another question on the unit handout. Here it is. Electronegativity differences between 0 and 1 and 0.3 nonpolar covalent. Electronegativity differences between 0.5 and 1.5 polar covalent. And then the one that I gave you already, 1.7 to infinity, is ionic. Okay? So, note, please, that figure 4.1 is all about the bonds. The bonds. Molecules are often made up of more than one bond. Okay? Molecules are made of more than one bond. In order for, now, so if I have a bond between two atoms that has a electronegativity difference between these two amounts, then that's a polar bond. But to get a polar molecule, I have to have more than just polar bonds. So here is the rule for determining when you have a polar molecule in this class. Now we're really simplifying things here. Okay? There's a lot more to understanding polarity. We're going to get it down just to the single one important thing, but it's not the whole story. And that's why we have these unclear regions here, because we're not going to take into account the other factors that affect polarity. We're only going to deal with those ranges that we can clearly identify as being nonpolar or polar based only on electronegativity differences. Okay? If you go to college, if you take high-level classes, you're going to have to know more about polarity than what you're going to learn in this class. Okay? All right. For a molecule to be polar, you have to have polar bonds, and for a molecule to be polar, you have to have polar bonds, and those bonds have to be unevenly distributed. For a molecule to be polar, you have to have polar bonds, and those bonds have to be unevenly distributed around the central atom. Okay? Around the central atom. All right, so let me give you a kind of an example of this that we can kind of look at. All right? Let's look at a bond or a molecule we form between carbon and fluorine. And then let's also look at a molecule we form between oxygen and fluorine. Okay? All right. I'm not going to review back all the stuff we learned in Unit 2 and 3 about how to build these molecular shapes. I'm just going to show you the molecular shape for this. You should know how to do this. If you need help with this, I'm always trying to be here as much as I can after school. I can't be here today, but most days I'm after school. Most days I'm here after school to help you if you need it. All right? I'll be here in the morning. What time do you want me to be here?
5. Can you move the little mouse thing on the laptop?
Say what now?
Can you move the little mouse thing on the laptop?
Move the mouse thing?
Ooh, your mouse.
Gotcha. Get out of the way there. All right. All right, when you build the molecule correctly, you get a tetrahedral shape. Okay? This is a tetrahedral. Let's look at the polarity then for a minute. If you get out your periodic table with electronegativities, we can find the electronegativity of fluorine and carbon. Fluorine is 3.98. So the electronegativity of fluorine is 3.98. The electronegativity of carbon is 2.55. That's the electronegativity of carbon. And so the difference is 1.43. That's the electronegativity difference for a bond between carbon and fluorine. Let's get your unit handout out and take a look. And an electronegativity difference of between 0.5 and 1.5 is polar. Therefore, all these bonds are polar. Okay? So the bonds are all polar. But the bonds are also evenly distributed around the central atom carbon. Okay? For it to be a polar molecule, I have to have two things. Not only do I have to have polar bonds, I have to have uneven distribution. This is not unevenly distributed. Every angle of bond here is 109.5 degrees. Okay? This then is a non-polar molecule. A non-polar molecule. Because the bonds are polar, but they are arranged evenly.
So a tetrahedral is non-polar.
Not necessarily. Okay? Exactly. Now this molecule here, if you do everything you're supposed to do, the electron pair shape and the modified electron pair shape will be tetrahedral. But the molecule itself will end up being bent if you know how to do all that stuff in the last unit.
So we just do the two atoms, not the whole molecule?
Well, we're looking for the whole molecule, but usually for this class we're only going to have to worry about one or two bonds. We'll keep it pretty simple. So there's the electronegativity of fluorine. The electronegativity of oxygen is 3.44. That's the electronegativity for oxygen. And so that's, let's see, 454, right? That's the electronegativity difference for an oxygen to fluorine bond. Well, that's also polar. Okay? So these are polar bonds. Polar bonds, but look, they are not evenly distributed. This is an uneven distribution. Yes? You're just about to leave the class. Okay? So, why? That's right. 109.5 degrees here, but nothing up here. Okay? So that's going to be a polar molecule.